Hello lovely people, welcome back to my channel. If you are new to this channel, hello, my name is Shagun and you're watching Learn with Shagun. So I have started a series of these naming reactions on my channel in which today I'm gonna discuss Fittig reaction. This would be the second video of this series. Earlier we discussed Wood's reaction. So Fittig reaction, dear people, is also a variation of Wood's reaction only. Okay, so there are three reactions which are similar on a large scale. One, Wood's reaction, second, Fittig reaction, and the third one, which would be a hybrid of Fittig and Wood's reaction, that would be Wood's Fittig reaction. Okay, as I said, that Fittig reaction is a variation of Wood's reaction only. So in Wood's reaction we were dealing with alkyl halides, right? So only difference is in Fittig reaction is we are gonna deal with aryl halides here, and hence as a result we are gonna get these biaryl compounds, or you can say you may get symmetrical phenyl compounds or aryl compounds as the byproduct in this reaction along with the less needed one. Okay, so you may wonder that why I have written these three forms of reaction right here. So this I have written to make you clear that if any of these three forms of reactions come across anywhere, whether on the textbooks or internet, all of these means the same. See, this this means aryl okay group, this also means aryl halide, and this form C6H5X, this also means aryl halide. So all of these if they come, all mean the same. Taking equal quantities, that is 2 moles of this aryl halide and 2 of those sodium, metallic sodium, both of them combine. Okay, and this sodium, this takes off the halide ion from this aryl group, and it takes it away and forms a sodium halide. Now what's left? We are left with 2 aryl groups join with each other and they form a diphenyl, or you can say a symmetrical phenyl compound, okay, or aryl compound. Okay, so this is what this reaction is about, and let us see an example. So here we have taken bromobenzene. Okay, so bromobenzene is there and metallic sodium is there. In the presence of diether we have taken them. See, since there are 2 bromobenzenes, so there would be 2 bromines, and since there are 2 sodium atoms, so each sodium is going to take each bromine, going to form 2 sodium bromide. Each phenyl group is going to be left on each side, so 2 phenyls are going to combine and they are going to form diphenyl compound as a result. Now let us look into the mechanism of this process, and I'll tell you it is all similar to its reaction. Instead of alkyl halide you are gonna take aryl only. Okay, so if you want to mention the mechanism, like putting aryl right here, you can mention Ar right here, you can mention it like this also, and if you want to draw a benzene and then you want to depict it, then also it's okay, it's your choice. But for our convenience, let us look into the simpler version of it. So 2 sodium atoms are there, so they are gonna form their ions right here. These are the cations which are being formed, and 2 electrons are being released in that dry ether which we have taken, which we have used as a solvent, right? So here aryl halide is there. So aryl halide and this halide ion, obviously it is more electronegative. It is gonna pull the this electron density towards itself, which generates a partial negative charge on it, and as a result partial positive charge is generated on the aryl group, right? Now this electron which is being released in the system, one electron from that is gonna attack this, because obviously this would be a positive charge, right? So any of the electron in the system would get attracted towards it, right? So it gets itself attached right here, as a result of which these 2 electrons which are present in this bond, they go to this halide ion, and as a result X negative is being released in the system. Okay, so this electron, when it gets with the aryl group, it forms an aryl radical. Similarly, this step is going to repeat itself, right, with the other aryl halide, since we are using two aryl halides, right? So with the other aryl halide, same process is gonna repeat, and second electron transfer is gonna take place. Okay, now one more aryl radical is gonna form along with one this halide ion. Okay, so these two aryl radicals are being formed inside the dry ether. Now I have already told you in my previous video that these radicals are very much reactive and unstable, so they are gonna try to combine with each other. And also I told that these still require one more electron because they have got only one electron, so they are also one electron deficit right now, no? That's why these are very unstable. So that's why in third step dimerization takes place and product formation takes place, because still see, one electron here, one electron here. Okay, both of them are gonna form bond and share that electron, as a result of which they are gonna form a diphenyl compound. Aryl group got connected with the aryl group and they formed a diphenyl compound like this only. Okay, so here what's left? We are left with two sodium cations and anions. These one anion this, another anion this, are as a result of two acets. So both of them are going to combine with each other and they are going to form a sodium halide. Okay, so what we discussed previously was the free radical mechanism, and let us have a look on an ion mechanism also. So here step 1 would be ion formation. Again it would be the same, like sodium is going to release two electrons and going to form two sodium cations in the system in dry ether. Lekin here what changes? This aryl halide, now it directly forms the this aryl halide, it is going to directly form the ions instead of forming that radical thing. Okay, now formation of carbon ion is going to take place. How? See, one aryl halide, it did what? It directly formed the ions. So what's gonna happen here? This aryl cation, it is gonna gain two electrons from the system and it is gonna form, which was released by the sodium atom, right? So it is gonna gain those and it is gonna form a carbon ion right here. Okay, as a result of gaining these electrons. Now in the final step, the nucleophilic attack, SN2 like attack is gonna take place. So this carbon ion, it will attack the other molecule of aryl halide. What it will do is, this carbon ion, it will attack, since there is a partial positive charge on it and partial negative charge on this one, right? So it will attack this partial positive charge, and as a result this bond will get broken and this halide ion is gonna get away. Carbon ion is gonna get combined with this another aryl group, and as a result they are going to form a diphenyl. Okay, so this is how it takes place. So I hope you understood the mechanism, and for more videos like this, stay tuned to the channel and the more naming reactions are gonna come next.